Okay, let's keep going with this example. Now we have part C. If you recall, what we're asked to do is identify any x values where the function is discontinuous. And then we'll even go a step further and name which type of discontinuity it is. And then we'll state the intervals where the function is continuous. Okay, so now we have a full-blown piecewise function. This is great, part C. F of x equals x squared when x is less than or equal to 1, and it equals 3x if x is greater than 1. Okay, well, let's think for a second. Where might this be discontinuous? So you think, well, if it looks like x squared for all values less than or equal to 1, then it's going to be continuous when it's less than 1, right? It's just going to be x squared, no problem. And on the other side, 3x, it's going to be continuous when you're greater than 1 because it's just that line. The only point in question is that transition moment when x equals 1. Okay? So even though when x equals 1, you would use x squared when evaluating, there's that transition happening. So when you get to the other side of 1, you know, did it remain continuous or did something happen there? So the best way, to approach something like this is just, go back to the definition of continuity. So if you remember, the limit of f of x as x approaches a has to equal f of a. All right. And now what we're thinking of, again, the one point in question is that transition at 1. So let's begin by trying to figure out the limit of f of x as x approaches 1. And then we'll think about f of 1 and we'll see what happens here. All right. Now, even finding this limit is going to be challenging because you think, okay, a piecewise, so, how is this going to work? Like, we can't just plug something in. There's no simplifying and, like factoring and canceling here. We need to look at both sides of 1 separately. We need to take the limit as x approaches 1 from the left, figure out what that is, and we need to take the limit as x approaches 1 from the right and figure out what that is. And, well, they need to equal each other. So even just this part, is this true? Does this equal? We don't know. Okay, so let's look at both of these and see what we get. Okay, and there's kind of the question. I'm sort of saying it again. Does the limit of f of x as x approaches 1 equal f of 1, right? So that's just the definition. And then looking at the limit, and it looks like I set it up exactly the same way. Okay, well, I would say geniuses think alike, but, it was me doing both of these, so I don't think that counts here. All right, well, I'll just show you my work here for the left and for the right. So the limit of f of x as x approaches 1 from the left. Okay, so when looking at it from the left, well, which of the two pieces do we take? Do we take the x squared or the 3x? Well, on the left, number's a little bit smaller than 1, so that's less than 1. We'll use the x squared. Okay. And, well, we'll just plug the 1 in and get 1. Okay, very nice. As x approaches 1 from the right, then we look at values a little bit bigger than 1, so we're going to take the 3x. And all we got to do is plug it in, and we'll get 3. Hey, on the left, it approached 1. On the right, it approached 3. So I'll just show you all this now. So they're not the same value, so that means the limit of f of x as x approaches 1 does not exist. Now, this would be plenty. This would be all the information that we need to claim, yep, it is not continuous. This function is not continuous at 1 because, well, that didn't even exist. So it certainly can't equal anything. But just to affirm the point, I sketched the graph of that piecewise right over here. So there's x squared. It looks like x squared all the way up to 1 and including 1. So I got a closed dot there. But then at that moment, it skips up to 3x. So right then, 3x, well, there's an open circle, but it would be at 3, right? Because 3 times 1. And then it continues with a slope of 3 from there. So we get that big jump happening. Okay, so we can claim, let's keep it all on the screen. Yes, it is discontinuous just at 1. That was the 1 point in question, and it turned out to be discontinuous, and it's a jump. Okay, now having that graph is nice, and if you can maybe sketch that by hand, like on a quiz or a test, that might be helpful. But we don't really even need that, because as soon as we get the left side and the right side don't equal each other, then we know it's a jump discontinuity, right? Because it was at 1, then it jumped to 3, right? 1 to 3. It's not a hole. It's not an asymptote. That is a jump. Okay. So then where is it continuous? Well, everywhere else. So we'll just skip over 1 from negative infinity to 1, union 1 to infinity. Sorry, that's a little small and a bit fuzzy on the screen as I'm looking at it. Okay. So I've got one more example for us, and it's a pretty good one, a very applicable one for us. A sort of situation that we would encounter continuity in our day-to-day life. So I've posted an example problem just above this lecture video. So it's a PDF. Go ahead and open it up. It says 2.3 example at the top. So it was just too much for me to write all this out for you, and I didn't want you to think like you had to copy it all. So I just went and typed this example up. So if you need a moment to open that, maybe go ahead and pause the video now. And I will now read this question. So it says, an engagement ring saleswoman's monthly income is determined as follows. So she gets a base salary of $2,500 per month. Okay, not bad. But of course, she wants to make sales and make some commission, right? She's selling engagement rings. All right. So she gets her $2,500 a month, no matter what. But then it says all sales over $10,000 for the month receive an additional 5% commission. So if she's just making her sales and she sells under $10,000, she doesn't get any commission. She just gets her $2,500. But if she goes over $10,000, then she'll receive an additional 5% commission. And here's the really cool part. She will get 5% commission on all of her sales. Oh, let me read that a little bit closer. All sales over $10,000 for the month. Okay, I take that back. She only gets 5% commission on what she has sold that is above $10,000. So if she sells $11,000, then she'll get 5% on the extra $1,000. Okay, that's nice. And then if monthly sales are $30,000 or more, then she gets a bonus. So she's still making commission as normal, but as soon as she hits $30,000, now they're going to give her a $1,000 bonus on top of the commission and her base salary. Okay, not too bad. All right, so we're going to say let I of X represent the monthly income for the sales of X dollars worth of merchandise. All right, so part A, and this is challenging. We're going to graph I of X for X between 0 and 50,000. So any sales that she might, X is the amount of sales in dollars for the month. Okay, so anywhere between 0 and 50,000. Hopefully it's not 0 for this lady. Okay, so here we go. back on the screen. I'm just going to turn this paper around so we don't see that writing. So this is the document example, okay? And in part A, we've got the graph. Now, I'll show you the graph and then we'll talk through it. Okay, let's see. So let's see here. Let me try and get that a little bit closer. Okay, there we go. Graph I of x for 0, x between 0 and 50,000. All right, so we see what's going on here. Okay, so here's 0, obviously 0 sales, right? There's x, and there's I of x, and I've labeled it kind of in a way that was conducive to the dollar amounts they're giving us. So $2,500 is her base. And then I've marked 3,000, 4,000, 5,000, 6,000 up, going up that way. So we know if she doesn't sell $10,000, then it's just going to be, she's just going to get her base salary, right? 2,500. Okay. Then at the moment she hits 10,000, now she's making commission, right? And I think I need to make a correction here because I think I was interpreting it the way I first read it to you guys. We're going to have to fix something here. Let me erase all this. This will be good. We'll do it all together. It's better that way anyway. Okay. Okay, once she hits 10,000, now she's making commission. So all sales over 10,000 get an additional 5%. And that's going to hold up until $30,000 worth. So let's mark 30,000 down here as well. And there's 20,000, by the way. Okay. So as she begins to make commission on sales over $10,000, what's going to happen? Well, it's going to start to angle up, right? Let's think about how much commission she would make if she sold exactly $30,000. Okay, so she's making 5% commission. I'm grabbing my calculator here. I'm putting in 30,000, but she only gets commission on what's over 10,000. So I'm going to subtract 10,000. She doesn't get any commission on that. So she's going to get commission on $20,000 worth of merchandise. And it's 5% commission, so let's multiply that by 0.05. So if she gets up to 30,000, she's going to make an additional $1,000 that month. Okay. Okay, let's go back here. And I'm going to, looks like I've got some correcting to do live, sort of live here while I'm filming this. Well, that's how it goes. Okay, so let's make this 3,500, right? So when she gets to 30,000, she's going to make an extra $1,000, and it's going to connect right there. So that's going to be a closed dot, because that's going to be, now it's starting to angle up, and at this point she's at 3,500. But now at the moment she hits 30,000, she gets a $1,000 bonus. So I actually should not make this a closed circle. That should be an open circle. Because as soon as she hits 30,000, boom, up another 1,000. Okay. And so that's actually where the function value is at the $30,000 mark. It's going to be up here at 4,500 because she'll make her 1,000 from the commission and then another $1,000 bonus. And then if she continues to make sales up all the way to 50,000, well, she's just going to keep earning that 5% commission. So let's see, 50,000, but we already took into account all the way up to 30,000. So that's another $20,000 in sales times 5%. She's going to make another $1,000. So she'll be at 5,500. Thank you for your patience with my corrections on my own work that I did not have correct. And she'll be up at 5,500 for the month. Not bad. If she makes $50,000 worth of sales, I don't know how easy or difficult that is. I mean, engagement rings are not cheap, and you typically sell 2 at the same time. There's 2 people involved. But even so, I mean, that's a lot of money, $50,000 worth of merchandise. Maybe they count, you want to get insurance for your ring and that sort of thing, which is a great idea, by the way. Okay, so there's the graph for part A. Okay, let's take a look at part B. So part B says, is I of x continuous at x equals 30,000? Is it continuous at 30,000? No. What's going on there? There's a jump discontinuity. So that is definitely not continuous. You get that bonus. Boom. Is I of x continuous at 10,000? At 10,000, yes. Now there's this bend, but the limit on the left equals the limit on the right, which is the function value there at 10,000. So she starts to make commission, but it's all connected. Versus when she gets that bonus, right? That's not connected. Okay, very nice. That is the end of 2.3, continuity. Go check out homework.